Do not attempt to make any of the devices shown in this video. This information is presented for the benefit of persons with an interest in firearms science and who just want to know how things work. We now examine the construction of improvised suppressors. Our first unit is designed for the .22 caliber pistol. The body of the suppressor is made from ordinary 1-inch steel electrical conduit. It is cut using a pipe cutter. This achieves a flush, smooth end. Standard 1-inch grommets will provide our baffles. These grommets fit nicely inside the 1-inch steel conduit and are therefore self-aligning. Sometimes the grommets will require a little bit of grinding to achieve this ideal fit. The 1-inch steel conduit at top is 1-inch inside diameter. The aluminum tubing below is 1-inch outside diameter. This means that the aluminum tubing slips inside the 1-inch conduit. The aluminum tubing will provide spacers for our grommets. The standard 1-inch grommets thus fit flush and even with the 1-inch aluminum spacers. Brass tubing is also available in 1-inch outside diameter. In this first design, a piece of brass tubing will be used as a barrel extension. This tubing has the same outside diameter as the holes in the grommets. Cuts are made in the barrel extension to allow the gas to escape into the dampening materials. A high-quality epoxy is used to attach the grommets to each end of the barrel extension. A piece of steel screening is cut the length of the space between the two grommets. The steel screening is then wrapped around the barrel extension. Rubber bands are used to temporarily hold the screening in place. The screen is then secured with metal twist ties. Using a technique of the Class 3 manufacturing pros, white lithium grease is added to the screening material. This will help cool the hot expanding gases. A small piece of screen is rolled up and inserted into the aluminum spacers as well. It expands, providing the bullet path. In the actual assembly, lithium grease would be used on this screen as well. Let's examine the main components of this assembly. First, we have the nut epoxied into a end cap, followed by the barrel extension relieved to allow the gases to escape. Next come the aluminum spacers. Between each is a grommet. At the end, a rubber wipe. The first bullet will cut the hole through the rubber wipe. An electrical conduit end cap will complete the assembly. These electrical conduit end caps snap fit into the 1-inch conduit. This first design for the .22 caliber pistol will make use of the commercially available muzzle adapter couplings shown earlier. A nut with threads that match the muzzle coupling is epoxied to the inside of the electrical conduit end cap. A hole is cut in this end cap just large enough for the muzzle threads of the adapter to pass through. The standard nut fits nicely in the end cap. In the actual assembly, it will be epoxied in, and the hole will be larger. The end cap is coated with epoxy and then tapped with a hammer to seal the unit. A wooden dowel is used to aid in the assembly of the suppressor. First, the barrel extension, followed by the aluminum spacers and a grommet. Note that the grommets are inserted pointing in towards the muzzle of the weapon. The spacers are stacked with a grommet between each spacer. With the aid of the wooden dowel, the entire assembly can then be inserted into the 1-inch conduit body. The wooden dowel is then removed and the final rubber wipe inserted. In the actual assembly, the end cap will be epoxied on. A coating of flat black paint, and our unit is ready to test. Units of this type design register approximately 70 decibels. Note that at 71 decibels, our .22 conduit suppressor is a little bit louder than the book drop and a little quieter than the balloon pop. Our second unit uses a PVC suppressor body. The nut has been epoxied into this smaller piece of PVC tubing. In the actual assembly, this part would be inserted with PVC cement to secure it to the suppressor body. In this design, a barrel extension is not used. A piece of metal screening is flattened out and the steel wool spread and pressed against its surface. A wooden dowel is used to roll the steel wool up in the screening material. The screening material will be secured with a piece of copper wire. Our 1-inch OD aluminum spacers used in the previous design will be used here to cap each end of the screen and steel wool assembly. This will allow this assembly to be inserted into the PVC body more easily and will also align the bullet path. Removing the wooden dowel, we can observe the bullet path. In the actual assembly, the aluminum spacers would be epoxied. The entire assembly is then slid into the PVC body. The PVC body has an inside diameter of 1 inch. The wooden dowel is used to recheck bullet path alignment. A grommet is added, which secures alignment, and a small rubber washer in preparation for our final wipe. Our final wipe will be cut from this thick piece of rubber. A piece of the PVC tubing will be used as a template. And the wipe simply cut out with scissors. The rubber wipe is inserted inside the PVC end cap. The first shot will establish the bullet path through the PVC wipe. The PVC end cap containing the wipe is then pressed over the PVC body. In the actual assembly, this part would be secured using PVC cement. The PVC cement makes a very secure and easy hold. However, it makes a permanent installation. The caps cannot be removed to replace parts of the suppressor. This design proved more effective than our conduit unit shown previously. This PVC unit registered 63 decibels, slightly louder than the pellet gun. The unit was also longer and thus had more internal volume, but the use of screen instead of a cut barrel extension likely accounts for the superior performance of the PVC unit. The bottom line is that how loud something sounds is quite subjective, being interpreted by the brain through the sensor of the human ear. A firearm suppressor works much like an automobile muffler, which cools and baffles the hot gases of an internal combustion engine before they exit the tailpipe. Likewise, a suppressor cools and reduces the hot expanding, higher velocity gases produced by the burning propellant of the cartridge. Machine tools provide the ideal solution to both the alignment and attachment problem, and can use metal rather than flexible rubber wipes due to the precise tolerances machine tools can maintain. Without the benefit of machine tools, improvised suppressors must use rubber wipes. These burn out fairly quickly and affect accuracy since they often touch the bullet as it exits the wipe. Machine tool units are thus more durable and can be made so precisely that the bullet never touches any internal wipe. This makes machine tool units more accurate, but as we have demonstrated, improvised units can be just as quiet as the best machine tool manufactured units. Finally, though silencers are portrayed in the movies as instruments of spies and assassins, no suppressor is so efficient that the shot cannot be heard nearby. The reality is that suppressors were once popular items with sportsmen and target shooters simply because, in reducing noise and muzzle blast, they make firearms more pleasant to shoot. I hope you found our video entertaining and informative. Thank you.